Aubrey. Do we have audio on Discord? Harlow. Maybe not. 1, 2, 3. 1, 2, 3. 1, 2, 3. One, two, three. Harlow. 1, 2. 1, 2, 1, 2. Can't be sure about Discord. All right. Let's do this. VK3 Echo Kilo Hotel. Good evening. This is VK3 EKH, the official station of the Astronomical Society of Victoria, with the regular Friday night broadcast coming to you from the studios of VK3 CSJ in Narre Warren South. We're broadcasting on prime frequency of 3541 kilohertz in the 80 metre amateur radio band, and also via the Melbourne television repeater VK3RTV digital channel 1, and streaming on Discord, my H2 stream on Discord, and also on my YouTube channel on YouTube. Where else would it be? Type in VK3 CSJ in the YouTube search engine and look for the live indication, and you should find the YouTube stream if it doesn't fall over in the meantime. Very pleasant good evening to everybody on this 11th of July 2025 as the police helicopter hovers around overhead in Narre Warren. All right, it's going to be a quick session tonight. I generally say that every Friday and I still fill up the whole hour, but I've rushed to get a few things together tonight, and if it all works I'll be surprised. But nevertheless, we'll see how we go. We also have an email address, vk3ekh@gmail.com, which I'll just turn that inbox on so I can see what's happening. So if anybody is happy to send us reports on tonight's transmission, signal reports, let me know that audio is okay everywhere. That's the main thing, because I'm really unsure how things are happening at the moment. I've been fighting with this Behringer mixer, and it's just been annoying me. No, I don't want that. I don't know why it's reminding me of something here on the screen, so go away. vk3ekh@gmail.com, and we're just monitoring that inbox as we speak. What's the other thing? vk3ekh@gmail.com, and I've got cables on the floor here. I'm trying to move my chair in, and the wheels keep touching the cables. All right. Okay. All right. Let's see. Sorry, it's going to be a bit disjointed, but then again, it's like that every Friday night. All right. The Astronomical Society of Victoria. Let me just find my alternative bit of blurb that I broadcast here. This will do. The ASV is a non-profit society for people interested in astronomy, attracting and catering for people from a wide range of ages and backgrounds, abilities and interests. First formed in 1922, the society has grown to over 1,000 members. Its activities are coordinated by a council of elected office bearers, section directors and ordinary councillors. The ASV has weekly activities at our two metropolitan locations, the Morley Community Village at the Melbourne at the Melbourne Observatory. And we host monthly Astro Talks at the Herbarium near the Melbourne Observatory. The Society's library is also located at the Melbourne Observatory and is open during our Astro Talks. Over 50 years, the ASV has played a major role in the care of buildings and facilities at the Melbourne Observatory. Our members conduct astronomy for the people gatherings throughout the year, bringing telescopes and astronomy to Melbourne's parks and schools. Check the calendar on the ASV website for details if you are interested in attending one of these events. The ASV is currently involved in a number of major projects. One of those is the restoration of the Great Melbourne Telescope, and also are currently working on the installation of a series of remote telescopes at our dark sky site, and once completed will be accessible to members of the ASV. Thanks to a generous donation from one of its most long-standing and respected members, the Leon Mao Dark Sky Site, located north of Melbourne, has a pristine night sky for deep sky observing. The ASV has a 25-inch telescope, a 40-inch telescope, and a wheelchair-accessible 16-inch telescope at the Leon Mao Dark Sky Site, and makes use of the existing telescopes at the Melbourne Observatory during some section meetings and our members' nights held once a month at the observatory. An annual yearbook is supplied to members, as well as a bi-monthly newsletter called Crux, which all members are welcome to contribute to. The ASV's logo shows the Southern Cross and the pointer stars, and it has a motto which, once translated from Latin, is "This way to the stars." The ASV is governed by a set of rules which should be read before applying for membership, and all that can be found on the ASV website at www.asv.org.au. What else? It is the 11th of July, which means that there should be a monthly meeting coming up. What was the date? The 11th. That's then. So there already was an Astro Talk last Wednesday, and I'm not finding any information on who that was on the calendar, so I can't tell you who it was. I completely missed the Astro Talk. I'm not really sure what transpired last Wednesday, 9th of July. The calendar just says to be announced, and doesn't really tell me who or what was being planned for the 9th of July. If anybody knows what transpired for the Astro Talk on the 9th of July, let me know via email, and we'll mention it. But I'm sure that if there was a Astro Talk for the monthly meeting, it would have been televised on the ASV website, on the YouTube, ASV's YouTube channel, which I'll go digging into a little later on, find out what was the presentation, and also on Facebook. So yeah. Anyway, so that was last Wednesday, but I have no idea what transpired. It's I remember mentioning this last week, and there was nothing there, so I don't know. So whoever looks after the calendar is not keeping us up to date. Anyway, enough of that. Alrighty then. Sky Notes. Now, I know I read the Sky Notes out courtesy of Dr. Tanya Hill at the planetarium. This young lass here, she every month compiles Sky Notes for the following month that we're coming into, and I know I've read them out already. I don't particularly wish to go through it all again. Let's see what can I pick up. Normally I just follow up on the events, and I think I went as far as I'll go from the 16th. What's the date? It's 11th. Let's see. Yeah, okay. Well, I know I mentioned this last week, but today, 1979, on the 11th of July, 1979, Skylab 1 is destroyed during a re-entry over Western Australia and scatters debris over a wide area. Yes, I was 19 years old when that happened. On the 14th of July 1965, Mariner 4 makes the first controlled flyby of Mars and returned the first close-up images of the planet. On the 15th of July 1975, Apollo-Soyuz test project mission occurs, and American Apollo module with 3 astronauts launched with the last Saturn rocket, and a Soviet Soyuz craft with 2 cosmonauts rendezvous and dock in Earth orbit. On the 16th of July 1746 is the birth of Giuseppe Piazzi, discoverer of the dwarf planet Ceres in the asteroid belt. Also on the 16th of July 1969, Apollo 11 launches to the moon for the first lunar landing 5 days later. Also on the 16th of July 1994, Jupiter is struck by over 20 fragments of comet Shoemaker-Levy 9, with Earth-based telescopes and Hubble Space Telescope observing the unique event. And I have just a little bit on that coming up in a minute. On the 20th of July 1969, Apollo 11 moon landing, when a lunar excursion module Eagle touched down in the Sea of Tranquility. On the 21st of July 1969, first humans set foot on another world. At 12:39 p.m. Australian Eastern Standard Time, Neil Armstrong becomes the first person to step onto the moon and is followed 20 minutes later by Buzz Aldrin, while the third Apollo 11 astronaut, Michael Collins, remains in the Command Service Module Columbia in lunar orbit. Armstrong and Aldrin are on the moon for 21 hours and 36 minutes. On the 22nd of July 1784, first use of parallax and hence calculation of the distance to a star by Frederick Bessel. 23rd of July 1995, Alan Hale and Thomas Bob discover comet now named after them, Hale-Bopp, I think it is. And also on the 23rd of July 1928 is Vera Rubin was born. And if she only knew that one of the biggest telescopes was going to be named after her, she would have been thrilled about that. 23rd of July 1928, Vera Rubin is born, famous for analysing the rotation rates of galaxies. 24th of July 1969, the first lunar landing mission, Apollo 11, ends with command module splashdown in the Pacific Ocean. And on the 30th of July 1971, the first lunar rover used on the moon in Apollo 15 mission. And finally, the 29th of July 2005, dwarf planets Eris and Make announced, leading to Pluto becoming a dwarf planet as well. And that concludes the Sky Notes for July, courtesy of Tanya Hill. Thank you, Tanya. And we wait with bated breath for August's Sky Notes. Oh, goodness me. All right. You're tuned to ASV Radio, VK3EKH. Okay, I'm getting... Will you stop that? Something wants to restart. I'm getting a note from VK3FST saying that Discord, no audio on Discord. Yeah, all right. I was a bit worried about that. Let me see about that. vMix is telling me there's audio there, so not that it's on Discord, of course, but let me see if there's something I haven't turned on. Just bear with me a tick as I look at the mixer thing. Why is this so? Why is it so? Let me have a look at this. Yes, I can see Andrew is there, Steve is there, and Sam. Bear with us. Oh, the outside light has just come on. Oh dear, I can see there's audio there, and I know there's audio going up through the ATV system. So for some reason it's not being channeled through to vMix, and that really is a very simple matter. Audio microphone. 1, 2, 3, 4, 5. Harlow. Oh, that's got it. Has that got it working? Looks like it's working. Somebody tell me that you're hearing me on Discord. Looks like it is, because usually on Discord I see a little green border show. So I think it is now working. Apologies for no audio on that. There's always something. Andrew is checking in, listening on 80 metres, 5 and 9. Thank you, Andrew. VK3KIS. Okay, you're tuned to ASV Radio. Now, let's go on to the next thing here. Where was I? Oh, yes. Just a little bit of a plug for Southern Astronomer. And let me bring up the little thing I've got for that somewhere in here. There it is. All right, so the latest from it's the special winter edition. It's called Southern Astronomer, the Astronomy and Science magazine, Southern Astronomer. And if you go to www.southernastronomer.com, Southern Astronomer being one word, you'll find out more information about this publication, which comes out only a couple of times a year, I think. Southern Astronomer is the Southern Hemisphere's most comprehensive online magazine for the latest news in science, astronomy, astrophotography, and space exploration. There is a subscription that's involved in that. Anyway, the latest, the special winter special edition is available. So if you're interested in that, just go, like I say, go to the URL and have a bit of a poke around. www.southernastronomer.com. And what you see on the screen right now is it. I haven't gone through it yet, so I'm not really sure exactly how it's been put together. But anyway, a plug for that. All right, next. We're on to... Oh, now this is interesting, I think, because it's the first I'm hearing about this. Let me bring up this guy's picture. As soon as I put it up, you'll recognise who it is. Astronomy.com, they're saying that on July 10, it's probably correct, but I wouldn't have called Nikola Tesla father of radio astronomy. But radioastronomy.com is saying that July 10, 1856, the birth of Nikola Tesla. Today in the history of astronomy, the father of radio astronomy is born, is what they say here. That's news to me, actually. It says here, the caption under this picture is, though his ideas seemed wild at the time, much of Nikola Tesla's work laid the foundation for future astronomy research and robotic space exploration. Inventor Nikola Tesla was born July 10, 1856, in what is now Croatia, then part of the Austrian Empire. In 1899, Tesla recorded cosmic radio waves in his Colorado Springs, Colorado laboratory. Though he believed the waves were extraterrestrial signals from another planet, today we know that they are part of the spectrum of the electromagnetic field emitted by astronomical objects, leading to Telstra being known as the father of radio astronomy. Now, I've never heard that. I have never heard Nikola Tesla being known as the father of radio astronomy. I'll have to research that one. But Karl Jansky, I would have thought Karl Jansky would have been considered, and as far as I know, the term father of radio astronomy was laid with Karl Jansky, because as we know, Karl Jansky developed a rotating antenna system to try and track down a noise that was interfering with telecommunication systems of that time. And by rotating the antenna system he developed, he was able to conclude that the noise causing interference on the systems that they were using at the time was actually emanating from space. And he was able to pinpoint roughly the origin of these signals. And that spawned a whole lot of things to do with radio astronomy. Karl Jansky wanted to further investigate this interference or signal noise coming in from the universe, but his would-be employer at the time said, "No, Nicole, Carl, you've done your research and go on to other and better interests and things." In fact, I read somewhere that Karl Jansky had thought of the idea of using a parabolic antenna to better focus on the sky, but funding wasn't there, and that never transpired. 10 years later, of course, Grote Reber followed up on Karl Jansky, and hence the whole aspect of radio astronomy was born. I know Nikola Tesla was an inventor, yes, and came up with a few interesting ideas. I've never read that he was able to receive what he thought were signals from outside the Earth. I have to investigate that. But father of radio astronomy, I just don't know. But astronomy.com here is saying that. Maybe there is some truth in that. We'll have to investigate that. Anyway, so this little article here, it continues on to say that leading to Tesla being known as the father of radio astronomy. In 1900, Tesla began work on I don't know how you pronounce this, Wardcliffe wireless broadcasting tower on Long Island in New York, planning for it to facilitate communication with other planets in the solar system. So first I've heard that. Though funding for the project fell apart before it was completed, many of his ideas were foundational to today's telecommunications industry. His work with remote controls was also a precursor to future space exploration. He demonstrated a radio-guided boat in 1898, laying the groundwork for computer-guided spaceships and robotic cosmic exploration. All right. Well, there he is. There's the guy. So, yeah. All right. Continuing on, let me give it back to vMix and bring up me. Hello again. All right, you're tuned to ASV Radio, VK3EKH. Next article I've got here is this one. Oh, yeah, okay. And most of us would have seen, although I think this is a bit of a compilation image, Comet Shoemaker Levy 9 is shown on its way to Jupiter in 1949 in this composite image. I wasn't too wrong from that. But that was a big event at the time. And I know that a lot of people were able to actually see this happening with their telescopes trained on to Jupiter. They were able to see these impacts occurring. In July 1992, Comet Shoemaker Levy 9 made its closest approach to Jupiter, skimming some 25,000 miles or 40,000 kilometers above Jupiter's cloud tops. That put Shoemaker Levy 9 within the gas giant's Roche limit, R-O-C-H-E, Roche limit, the planet's tidal forces broke the comet into more than 20 pieces, giving it a string of pearls appearance and setting the stage for a series of impacts. The fragmented comet was discovered in March 1993 by Carolyn and Jean Shoemaker and David Levy, and by May the forecast had been made. Shoemaker-Levy would hit Jupiter in July of 1994. The predicted bombardment occurred from July 16 to July 22, with NASA spacecraft in position to observe the events. The collision left huge dark marks on Jupiter's face and provided scientists with invaluable data on temperature, the presence of water, and the makeup of Jupiter's interior. So it was a pretty amazing time because there were all sorts of observatories focused on Jupiter. There was even an aircraft launched with a telescope and observing platform from an aircraft to try and get above the clouds and a better view of Jupiter, taking infrared imagery as well. And somewhere along the way I did download some time ago actual video footage of the impact of one of these fragments, and the way you could see this massive glow occurring. For me at the time though, I was just getting involved with the radio astronomy section of the ASV. Section director at the time was Lockie Creswell, and once we heard about this impact with Jupiter, we figured that it would be interesting to set up a number of receivers tuned around the 20 megahertz portion to see if it was possible to actually detect impact emission at around 20 megahertz. Now, the only reason why we use 20 megahertz is because it is possible to be able to hear decametric emissions from Jupiter at anywhere between 8.5 megs up to 40 megahertz are these emissions that come from Jupiter, and it was considered that maybe around about those higher shortwave frequencies it's possible to hear these impacts. So even Monash University had set up a similar receiver up at Mount Burnett Observatory. Actually, at the time there's a small reservoir up near the observatory, and an antenna was constructed and across the observatory, and there were shortwave receivers used to tuned in to around the 20 megahertz region. And nevertheless, our radio astronomy section, we had three receivers set up, one in central Victoria. I had one set up at home, and another fellow, a friend of mine, had a receiver going in Noble Park. And anyway, we all had NASA's predictions of when these impacts were going to occur. So on that basis, we were monitoring the receiver around 20-21 megahertz, and we were using chart paper to record the output from a receiver. And I've got meters and meters and meters of chart paper here. But between the three receiving stations set up at the time, we later correlated some of the chart recordings that were created. And again, on the basis of the time predicted by NASA, these fragments impacting with Jupiter, we were able to conclude an increase in the noise, a spike in the noise around about the same time at three different locations. And we made the assumption anyway, at least, that was impact of these fragments from Comet Shoemaker-Levy 9. And interestingly enough, what we didn't know at the time The late Doug MacArthur was also part of this investigation, and he trained his 30-foot dish antenna onto Jupiter at the time, and using his 400 megahertz receivers, he was able to also detect impacts at 400 megahertz, which was really interesting. We just weren't aware of that he was doing that at the time. It would have been interesting to have correlated with his research as well. But nevertheless, it was an exciting time in July of 1994, and it started my whole road into radio astronomy via the ASV. And I was with the radio astronomy section since that time, 1993 to 1994, and the rest is history, as they say. But it was an exciting time for a lot of people, and certainly the impacts that left marks on the surface or in the upper atmosphere of Jupiter were like bruises that stayed there for months and months and months. So it was really quite an exciting time indeed. All right, you're tuned to ASV Radio VK3 EKH, the official station of the Astronomical Society of Victoria, with the regular Friday night broadcast. Looking at the next thing I've got here. Oh yes, now this is an article I left over from last week. This was published 30th of June. Courtesy of astronomy.com, and the picture that starts off this article is this guy. Bring that up. All right. And it's titled How a Signal from a 60-Year-Old Satellite Baffled Astronomers for Over a Year. Radio telescopes saw a strange burst of unknown energy in June 2024. Now we know it was from something called Relay 2, a derelict early telecommunications satellite. Around midday on June 13 last year, my colleagues, the author of the article no doubt, my colleagues and I were scanning the skies when we thought we had discovered a strange and exciting new object in space. Using a huge radio telescope, we spotted a blindingly fast flash of radio waves that appeared to be coming from somewhere inside our galaxy. After a year of research and analysis, we have finally pinned down the source of the signal, and it was even closer to home than we had ever expected. Our instrument was located at the, its Aboriginal term here, will it ever finish? Anyway, our instrument was located at the Inyarmanya Yirjarbundara. The CSIRO Murchison Radio Astronomy Observatory will do me, in remote Western Australia, where the sky above the red desert plains is vast and sublime. We were using a new detector at the radio telescope known as the Australian Square Kilometre Array Pathfinder, or ASCAP, to search for rare flickering signals from distant galaxies called fast radio bursts. He says that we detected a burst, surprisingly, and it showed no evidence of a time delay between high and low frequencies, a phenomenon known as dispersion. This meant it must have originated within a few hundred light years of Earth. In other words, it must have come from inside our galaxy, unlike other fast radio bursts which have come from billions of light years away. Fast radio bursts are the brightest radio flashes in the universe, emitting 30 years worth of sun's energy in less than a millisecond, and we only have hints of how they are produced. Some theories suggest they are produced by magnetars, the highly magnetized cores of massive dead stars, or arise from cosmic collisions between these dead stellar remnants. Regardless of how they occur, fast radio bursts are also a precise instrument for mapping out the so-called missing matter in our universe. When we went back over our recordings to take a closer look at the radio burst, we had a surprise. The signal seemed to have disappeared. 2 months of trial and error went by until the problem was found. ASCAP is composed of 36 antennas, which can be combined to act like one gigantic zoom lens 6 kilometers across. Just like a zoom lens of a camera. If you try to take a picture of something too close, it comes out blurry. Only by removing some of the antennas from the analysis, artificially reducing the size of our lens, did we finally make an image of the burst. And this is this image here. Just bring that up. There it is. This is what they're talking about. The first radio burst was captured by using ASCAP's radio telescope, is the caption on this image. We weren't excited by this. In fact, we were disappointed. No astronomical signal could be close enough to cause this kind of blurring. This meant it was probably just radio frequency interference, and an astronomer's term for human-made signals that corrupt our data, he says. It's the kind of junk data we normally throw away. Yet the burst had us intrigued. For one thing, the burst was fast. The fastest known fast radio burst lasted about 10 millionths of a second. This burst consisted of an extremely bright pulse lasting a few billionths of a second and 2 dimmer after pulses for a total duration of 30 nanoseconds. So where did this amazingly short bright burst come from? And there's a little chart graph here as well, which looks a bit like this. And they're saying here that a zombie in space, they're saying. We already know, or we already knew the direction it came from, and we were able to use the blurriness in the image to estimate a distance of 4,500 kilometers. And there was only one thing in that direction at the distance at the time, a derelict 60-year-old satellite called Relay 2. Relay 2 was one of the first ever telecommunications satellites launched by the United States in 1964. It was operated until 1965, and its onboard systems had failed by 1967. But how could Relay 2 have produced this burst? ? Some satellites, presumed dead, have been observed to reawaken. They are known as zombie satellites. But this was no zombie. No system on board Relay 2 had ever been able to produce a nanosecond burst of radio waves, even when it was alive. And here is an artist's impression of this satellite. I don't know how close to reality it actually it is, but nevertheless, we have to assume that that's a fairly close resemblance of this relay satellite. We think the most likely cause was a electrostatic discharge. As satellites are exposed to electrically charged gases in space known as plasmas, they can become charged, just like when you rub your feet on a carpet. That puts my teeth on edge thinking about that. And that accumulated charge can suddenly discharge, with the resulting spark causing a flash of radio waves. Electrostatic discharges are common and are known to cause damage to spacecraft, yet all known electrostatic discharges last thousands of times longer than our signal and occur most commonly when Earth's magnetosphere is highly active. And our magnetosphere was usually unusually quiet at the time of the signal, it seems. Another possibility is a strike by a micrometeoroid, a tiny piece of space debris, similar to that experienced by the James Webb Space Telescope in June 2022. According to our calculations, a 22 microgram micrometeoroid travelling at 20 kilometres per second or more and hitting Relay 2 would have been able to produce such a strong flash of radio waves, but we estimate the chance the nanosecond burst was detected was caused by such an event to be about 1%. So ultimately, we can't be certain why we saw this signal from Relay 2. What we do know, however, is how we see more of them. When looking at 13.8 millisecond timescales, the equivalent of keeping the camera shutter open for longer, this signal was washed out and barely detectable even to a powerful radio telescope such as the ASCAP. But if we had searched at 13.8 nanoseconds, any old radio antenna would have easily seen it. It shows us that monitoring satellites for electrostatic discharges with ground-based radio antennas is possible, and with the number of satellites in orbit growing rapidly, finding new ways to monitor them is more important than ever. But did our team eventually find new astronomical signals? You bet we did, and there are no doubt plenty more to be found. Alright, well that was courtesy of Astronomy.com, and let's just go back to VMix. So courtesy of Astronomy.com, published on, where's the date? 30th of June. So I've been holding on to that article since the beginning of the month. How a signal from a 60-year-old satellite baffled astronomers for over a year. Most fascinating indeed. You're tuned to ASV Radio VK3 EKH, the official station of the Astronomical Society of Victoria, with the regular Friday night cast missions coming to you from VK3 CSJ at Narre Warren South. All right, at 18 minutes to 11, we have, this is an article published, it's May 5, I just found this. I thought this was interesting. I don't think I mentioned this on that week. Just trying to find articles very quickly. A speeding pulsar may have broken this cosmic bone. Now, it's an interesting picture here. I'll bring it up. Where are we? There it is, just there. Right, what we're looking at here, for those watching the video side of this broadcast, a bone-like galactic center radio filament perpendicular to the Milky Way's disk has two strange kinks, at least one of which is likely caused by a passing pulsar. Right, so going back, a speeding pulsar may have broken this cosmic bone. NASA's Chandra X-ray Observatory helped diagnose the cause behind a large kink in a huge filament near the center of the Milky Way. All right. The Milky Way galaxy is full of cosmic objects of varying shapes and sizes, sometimes resembling objects here on Earth. A galactic center radio filament called G G359.13 for short, is seen here in X-ray blue and radio grey light. So the image on the screen is real. So X-ray is blue and radio is represented as grey. All right. Astronomers have likened the 230 light-year-long structure to a cosmic bone perpendicular to the galactic plane. G359.13 is ranked as one of the longest and brightest galactic centre filaments in the Milky Way. Astronomers aren't exactly sure how they form, but they do know that these filaments are threaded through with magnetic fields and become visible to radio telescope as energized particles spiral along these fields, emitting radio waves. This particular filament also has two kinks. Now, astronomers have discovered the likely culprit behind the bigger of the two, a rapidly spinning, extremely dense neutron star called a pulsar. A study published February 23rd in Monthly Notices of the Royal Astronomical Society shows that the pulsar is estimated to have crashed into G359.13 at speeds between 1 million to 2 million miles an hour, or 1.6 million to 3.2 million kilometers per hour. The pulsar likely slammed into the filament and perturbed the magnetic fields, resulting in the kink. The pulsar is visible thanks to its X-ray emission and appears smack dab within the deformed filament. The study also argues that the filament's secondary kink may be caused by the same object, although it is also likely the smaller kink was caused by a different source. The X-ray data came from the Chandra X-ray Observatory, and the radio data came from both the Meerkat Radio Observatory in South Africa and the Very Large Array in New Mexico. So that's a fascinating image, all photographed using different wavelengths of light, not an optical telescope, but X-ray and radio, and this is what can be seen in our universe. It is really an amazing thing indeed. Right. Next is, what is next? Oh yes, right. There's a video YouTube thing attached to this, but I won't. I'll play it while I read the article, but I'll kill the audio, so there's nothing being played over. Anyway, we're coming up to the end. Next is spaceweather.com information. Could a paper plane thrown from the International Space Station survive the flight? Now, why would you even bother doing that? 10th of July 2025. This is courtesy of sciencealert.com. And there's a little picture here of somebody with a paper plane. Let me just show that. If I did I bring that up there? Did I bring that? Did I bring it? No, I didn't. Did I save it? Actually, let's just have a quick look at my image list, because I thought I did. Yep, there it is. Didn't bring it across. Okay. Here, of course, is a picture of a paper plane. We've all seen one of those. Sometimes there are profound questions in life that must be answered, like, what is the meaning of life? Are we alone in the universe? Or what happens if you throw a paper airplane from the International Space Station? I know that gets asked all the time. Luckily, that third one has finally been answered, because, of course, someone would eventually. A new paper from Maximilian Berthert, and it's a Japanese name, and Kojiro Suzuki from the University of Tokyo looks at the dynamics of looks at the dynamics of a origami space plane during Earth atmospheric re-entry. In other words, what happens when you throw a paper plane out of the International Space Station? First, let's go over some technical ideas that are necessary to understand this seemingly simple concept. Origami literally means folded paper in Japanese, and in this case the authors decided to make their paper airplane out of standard A4 sheet of white paper. The end result looks like something a third grader would have made up to annoy their friend sitting in front of them in class, but with a lot more aerodynamic modelling. Once the software model was made, it was first put to the test. The International Space Station orbits around 400 kilometres, so the authors decided to launch the plane from that height and at a speed similar to that of the International Space Station itself, which is something like 7,800 metres a second. Now, that's interesting. You know, we all know that the International Space Station orbits around 400 kilometres above the Earth. You know, that's where it's parked. But I've never really seen how fast it actually is travelling. I've never read that speed, the velocity of the International Space Station, but there it is. 7,800 metres a second. That's how fast it's moving. 7,800 metres a second. That's just amazing. That speed might seem likely. It would shred any plane made out of paper, but at 400 kilometres of altitude, the atmosphere isn't thick enough to do much damage yet. That's actually the case for the majority of the descent back to ground. From 400 kilometres down to around 1,220 kilometres altitude, the plane stays relatively stable given the lack of air. However, the plane descends very quickly due to its low basaltic coefficient, which is a measure of how well it can overcome air resistance. With its low basaltic coefficient, ballistic coefficient, the plane rapidly slows, descending to 120 kilometres in about 3.5 days. On the slip side, a low ballistic coefficient would mean that once the plane entered the atmosphere, it would actually have a lower terminal velocity than something like a cannonball. And there's a little graph thing, a picture that they're showing here, so I'll bring that up. No, I didn't bring that across either. Don't know why I didn't do that. Stand by. We shall go to my little image library and see if I did. There it is. Okay. Stand by. Wouldn't it bother you? All right. So there's a picture that they're referring to. Okay. So on the slip side, a low ballistic coefficient would mean that once the plane entered the atmosphere, it would actually have a lower terminal velocity than something like a cannonball. Unfortunately, it never makes it that far, as according to the simulations at around 120 kilometre altitude, the increased air density induces uncontrollable tumbling, essentially sending the plane into an uncontrollable flight path familiar to anyone who has ever made one of them. But why stop at simulations when you have a PhD in aerospace engineering and can build a paper airplane for science? And why just build one when you can test one in a hyper-advanced wind tunnel on your university's campus? The answer is you don't stop, which is why the authors built an actual paper airplane model, admittedly with an aluminium tail, and put it into a Kawasha airplane model. Put it into a Kawasha hypersonic and high enthalpy wind tunnel at the University of Tokyo to see what kind of aerodynamic forces their paper airplane would withstand. Oh dear. They didn't go easily, or that didn't go easily on the experiments either. Their 1/3 model paper airplane was subjected to Mach 7 winds for 7 seconds, similar to the forces experienced during an actual re-entry. This unsurprisingly bent the nose of the paper airplane back, but to its credit, it didn't disintegrate, at least not at that amount of time. There was also noticeable evidence of charring on the nose and the wingtips, indicating that if the experiment had gone on longer, the paper plane would have burnt up, ultimately proving that that's what would happen was one of the purposes of the experiment. There are plenty of mission architectures that could potentially use something similar to this paper airplane model. That Leaves experiment for Venus exploration comes to mind, but there are also plenty of Earth observations that could benefit from a lightweight, stable platform to do their collecting from, with burning up completely in the atmosphere at the end of the life. Mounting any such mission would require electronics and many other additions that would complicate the purity of testing a simple paper plane that a kid could have made a class. But sometimes science is as much about inspiration as it is about exploration, and the results in this paper provided a nice mix of both. Right, and there is a video associated with this article, which I didn't play, but there is something there. So if you want to follow up, go to sciencealert.com and look for the article titled "Could a paper plane thrown from the International Space Station survive the flight?" And it seems not, really, at the end of the day. All right, fine business. Let me see. Where am I? This is the last of this tonight. We're going across to space weather. Yes, space weather. That's where we are. All right. The solar wind is currently at 462.5 kilometers a second at a density of 2.36 protons per cubic centimeter. The current disk of the sun looks a bit like this, with what is it? 1, 2, 3, 4, 5 sunspots. Not too many to write home about, but that is the current disk of the sun. If we could look at it here, the sunspot number is 72 for the year so far, and the radio sun is currently at 129 solar flux units, measured at a wavelength of 10.7 centimeters. The radio sun flux. The aurora over Antarctica is currently looking like this. So there's actually a fairly obvious oval over the Antarctica at the stage. There's a yellowy tinge to it. There's no red tinge to it, so it's only producing a moderate amount of 50% sort of activity at the moment. If you're in southern Tasmania, you'd probably see a hint of a glow on the horizon. But that's the aurora over Antarctica happening as we speak, and the coronal image. No, don't do that. Go away. Is looking like this at the moment. So there's a massive hole which is spewing out charged particles, and so they're saying here that what are they saying? Doesn't appear to be any solar activity at the moment to to be of any great concern. What else we're seeing here on spaceweather.com is something about Saturn. Oh, I see. I do remember something. They were saying something about charged particles hitting Saturn, causing. What they're saying here: nothing hit Saturn after all. A few days ago, we reported that something might have hit Saturn, and there's an actual impact image. I didn't see that. On July 5, appeared to signal an asteroid or comet collision. However, astronomers working with with a certain project failed to confirm the flash in additional images. So they're saying that nothing hit Saturn after all. Let me just have a quick look at this impact flash. Okay, so it's not a movie, but it's a fixed image, and they're highlighting just a very subtle flash of some sort to this image. So what it was is still a little they're not too sure what it was. Let me see if I can quickly show you that to you. Let me just bring it up. I can just quickly save this to vMix, and I can bring this up very quickly so you can see what I'm talking about. It is this image here. Alright, stand by. There it is. See, just a few clear clicks and we can get it. They report on a potential impact flash observed in Saturn. This is a copy of his alert, of the author's alert. There is a tiny chance that a very short impact flash occurred on Saturn, July 5. This is very important. We could get other videos of Saturn taken during this time frame that it says here. So that's it's on the screen there. It's not so obvious, but anyway, they haven't been able to correlate it. And according to Space Weather, they're saying that nothing hit Saturn after all. Oh well, there it is. Interesting stuff. Otherwise, there's not much else to report here on the Space Weather side of things. NOAA forecasts, they're saying that a chance of Class M flare is 35%. Class X is down to 0.1%, so there's not much chance of any flare activities occurring at the moment. The cosmic rays recording is actually on a decline, which is interesting. They launch a balloon into the stratosphere on a daily basis to record cosmic rays, and usually during a solar cycle, the cosmic radiation tends to reduce, and there's a 30% reduction since solar cycle 25 occurred, which is interesting. All right, and on July 11, 2025, there were 2,349 potentially hazardous asteroids. Potentially hazardous asteroids, or PHAs, are space rocks that are up to about 100 meters in size, and that could come close to Earth within 0.05 AU. But none of these known comets are on a collision course with our planet. But astronomers are finding new ones all the time. So, as I say, potentially there's 2,349 potentially hazardous asteroids, but none of them are on a collision course with Earth, which is good to know. So I think on that note, we can conclude today's session at 11 o'clock, 11:03. We still managed to take up the hour, which amazes me. Well, it doesn't amaze me, actually. So, all right, bring back to the live camera. I'll stick to that one, I think. All right. So We covered Sky Notes. We covered the Southern Astronomer magazine. Like I say, go to www.southernastronomer.com for more information on that. We talked about Nikola Tesla being the father of radio astronomy, which I have great questions over, reservations over. We talked about Comet Shoemaker-Levy 9 impacting on Jupiter. A derelict spacecraft called Relay 2 produced a nanosecond radio signal which had radio astronomers baffled for over a year. And a speeding pulsar may have broken the cosmic bone. That's an interesting image. And could a paper plane survive a being launched from the international? Look, the only interesting thing about that article: could a paper plane thrown from the International Space Station survive the flight? Really, as if there's other things to think about. But the only thing that was really redeeming about that article was the fact that the International Space Station travels at 7,800 meters a second. That's most taining. All right, enough of that. Okay, where's my radio transceiver? There it is to the left of me here, and my pad and my pen. Are there any stations wishing to check in for tonight's session? This is VK3 EKH listening 3541.
Kilowatt 3 Delta X-ray. VK3 STS. VK3 AOB.
Okay, VK3 Delta X-ray, VK3 SPX, VK3 AOB. Is there any other stations? That list is growing every week. G'day, Greg. VK3 Delta X-ray, VK3 EKH.
And good evening there, Clint, and to others that have checked in. And good day to their group up there in Linton. VK3 AOB. Good signals all round, and the band as well. It was quiet tonight. Yeah, good broadcast there, Clint. And yeah, the paper plane, I just heard that somewhere. I can't remember where I saw it, somewhere, but anyway, noted that, and also the satellite becoming sending out a signal that was been dormant for some time, apparently. Strange things are happening up there. Seems to be something showing up all the time. So it's an interesting situation, and always interested, always listening to something that's different that's going on out there, Clint. Hope you're well, and hope the cats are well, and you're sounding good about 20 over there, Clint. Back over to you. And thanks for that. VK3 EKH, VK3 Delta X-ray, Greg and Audible.
Yeah, good on you, Greg. VK3 Delta X-ray, VK3 EKH returning, and just realised I had the wrong caption up on my video until now. No worries, Greg. I hope you enjoyed the section tonight. Like I said, I got everything together in the last half hour before going on air. Admittedly, I was watching the footy game on 7, and that wasn't interesting to me, so I went across to YouTube, and I was watching a few things on YouTube and promptly went to sleep. And I think I surfaced around about 10 past 9, and I thought, my goodness, that could have been 10 past 10. So I quickly came over to the computer and just slapped a few things together. So I haven't really been too much with it tonight. I haven't even had a cup of coffee yet, so I'm having a glass of ouzo. Water, actually. Thanks, Greg. All very good. There's an interesting thing on YouTube that I was looking at, following up on a discussion that I was having about the geology of Victoria. And there's an interesting fault line called the Moyston fault line, which was created a long time ago, where most of Victoria was covered with seawater, and there's a region, a part of Victoria in Australia that was above the ocean line. Anyway, there was a clash of plates, and this rift occurred, called the Moyston, as in the name of the town in Victoria, where this fault line is apparently. Oh, it was really interesting. You know, Victoria, from a geological point of view, is most fascinating indeed. Anyway, that's another story. Thanks, Greg. Across to you there, Steve. VK3SBX, VK3EKH.
VK3EKH, this is VK3SBX. G'day, Clint. Yeah, there's a few interesting things there. Good to do that paper plate experiment. I was all a bit unconvinced. Obviously, it was, going to be somewhat mangled by a massive wind. But I wasn't sure whether or not...
Today we are going to attempt...
...just to fluff it down to the earth, somewhat mangled. It was really burnt up, and I'm not sure they really answered that question. Anyway, maybe someone one day. And as for the father of radio astronomy, well, I googled that, and there seems to be some debate about the subject, but if you do Google father of radio astronomy, you get about 85 sites that say it's Carl Jansky, as you suspected, Clint. But there are a few...
360 camera on this thing. We're going to put a satellite GPS on this thing. But oopsie, it took over 200 hours to perfect the design. Yay. Anyway, now we gotta figure out how to get it to space. Thankfully, we've done stuff like this in the past. All you need is a styrofoam cooler, a weather balloon, and $1,600 worth of Wait.
Helium's that much?
It went up, it almost tripled.
Why? So now we made it to the exact location marked by the GPS, but something was clearly wrong.
What want you to notice?
Wait, hold on. Was it still in the payload?
Barely. I wish we knew how, but the side of that plane ripped off, and the GPS just fell out.
No wonder we didn't find anything yet.
What? If you want the best TV for games, movies, streaming...
There's one higher than that too. There's one higher? Yeah, we're just gonna need to see it very, very high. Is that it?
That's it.
Okay, we gotta do this quick.
Alright, we need to launch now.
Is it going? Is that gonna go? I don't know, it's going up. It's going up. Please, Lord Jesus, let that work. Oh my gosh. Please, Lord Jesus, let that work.
Ready? Fast forwarding.
How much helium later? Like...
Plane is going into the payload. We're good to go, Matt.
Alright.
That's what we're all wondering, Liam. Alright, guys, this is a moment of truth.
But we won't know anything until we find the payload.
Anyway.
I also realized the paper airplanes I put in it that were going to be backups weren't in it.
Oh, really? Well, technically, that's a foam airplane.
Well, it's a
got
paper
paper.
airplane holding a foam
paper
airplane.
plane to the upper atmosphere. So, whatever
Sequel, anyone?
This video is about to finish. Just there, it stops. So, I don't really know what the outcome of all that is, but there it is. You can see in the arrow this paper plane. So what the outcome was, I don't know. Have to watch the video to find out. All right, thanks, Steve. No worries at all. And yeah, I'm going to stick to Carl Jansky as being the Carl Jansky and Grote Reber were both the pioneers for radio astronomy. And whatever Carl Jansky did was just a little bit there on the side. So yeah. Across to you there, Brett, VK3AOB, VK3EKH.
Sorry, Clint. Good evening. And what's wrong with this? What's going on here? 1212. 1, 2, 3, 4, 5. Seems to be a lot of noise or something. I've got a noisy signal.
Sounds okay?
On the audio there,
Yeah.
If I regular, it just might be, I've got the knobs here, put the mouse on top of my, on top of the, sound there it is, that's what has twisted. Here we go, 12 o'clock, there it should all be 12 o'clock, there they are, they're at 12 o'clock. The mouse either gets to sit on top of the thing here, I'm sitting on a recliner with the, I'm working on photos on the computer, gets the editing and getting rid of spares and all that sort of thing. I just came across a photo I took of one 18th of January this year at 1:40 a.m. on the tripod in the moonlight out in the backyard. So the neighbour's house in their garage. There's a few stars in it. It's a time-lapse thing. It's quite an interesting picture. But looks good. Anyway, yeah, there you go. Yeah, interesting. Yeah, good job, as usual. Fine, interesting discussion. I didn't realise you could pick up and listen to planetoids crashing into planets on HS. There you go. Now, we should be complaining to God about the high number of asteroids. We get rid of a few billion and then we have a bit quieter sky. Anyway, there you go. Nothing much else to add. Back to you.
Okay, over. VK3AOB, VK3EKH. Yes, you must have had one of your levels up a little too high or something, because there was noticeable background noise being picked up by your microphone, and as a result of that background noise, we could actually hear the QSB, very slow QSB on your signal. At least that's what I think it was. But you wound back the gain a little bit here and there, and that kind of fixed that up. Anyway, not a problem. Yeah, look, I think that the greatest issue that both optical and radio astronomers have at the moment, at present time, the amount of satellites that are orbiting this planet, the amount of radio pollution, radio interference being generated by these sources, because all these satellites are deliberately beaming RF signals down to the surface of the Earth, so they all represent bright sources of light from a radio point of view. And despite the fact that these transmitters are precise instruments and operating on precise frequencies, from a radio telescope point of view, there's still a potential for overwhelming the front end of the satellite's receivers, and that's where the problems start to occur. So even from an optical point of view, these satellites are being an issue. I remember reading somewhere that the SpaceX low Earth orbit satellites, they're thinking about painting. It might have been in the last week's WI broadcast, that they're thinking about painting or coating the surface of the SpaceX satellites a neutral dark color to minimize the amount of reflection, light reflecting off these objects, which potentially could work. So which is a good thing. But yeah, so there's so much space junk up there. It's not good. So that's our first problem, is for astronomers in general, is the stuff that's orbiting our planet. So yeah. Anyway, all right. Is there any other stations wishing to check in before we conclude? VK3EKH.
Sounds like the idea there, Clint, turn them into stealth satellites.
That's it. Stealth. That's the word. Although it's probably, I think the horse is already bolted from the barn on that one. But at least from now on, any new satellites that go up there should, the manufacturers of these satellites should consider a way of stealthing them. Oh dear. Anyway, all right. You've been listening to another session of the Astronomical Society of Victoria's Friday night broadcast, coming to you from the studios of VK3CSJ in Narre Warren South. We wish everybody a very pleasant weekend. Stay warm, and we'll be back next Friday, barely, next Friday, to do it all again, and hopefully I won't have to rush getting stuff together. But anyway, thanks for listening and watching, and everybody that's been viewing. Let me just quickly check that. Okay, if Andrew and Steve are still watching Discord. I don't know how many might have been watching YouTube, but that's fine. And as far as email, because we've only just got a couple of stations, so thanks to Sam and thanks to Andrew for popping in there on the email. I think that's about it. This is VK3EKH concluding for tonight, this 11th of July. We'll see you all next week. Take care. Look after yourselves. Thanks, guys.
Yeah, thanks there, Clint. We'll send Musk up there to make his satellite stealth.
Sounds like a good idea.
Cheers, Clint. I'll catch you next week, I guess. And also to you, Greg. How come with the change of call sign, or are you working from the club? Yeah, working from home there. Yeah, cheers there, Clint. Working from home there, Clint. Yeah, Brett, I should say.
I'm out of here. Cheers, everybody watching the video. Just a bit tired. Okay, stand by for a test pattern.